Welcome to video 11-4B. We are on Explain 3 on page 614, as you can see here. And we've already talked about the angle, triangle similarity shortcut, but there are also two additional shortcuts for proving two triangles are similar. While we're on the topic of shortcuts, just a quick review. Remember, for congruence shortcuts, we have 5. And those are side, 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 angle, side, angle, side, angle, 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 side, and HL. So those are my 5 for congruence. Our new information today is that now we are up to 3 shortcuts, and that is all there is, you guys, for similarity shortcuts. And remember, that symbol is just our squiggle here. We know we have angle, angle that works. And now we have 2 more shortcuts that we're being told here at the bottom of page 614 are also valid. And that is side, 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 and side, angle, side. Now notice, as we're putting those in our list, you can see that they have parallel letters in each group of symbols, both for congruence and for similarity. So you want to make sure anytime you're talking about side, side, side similarity that you add the little squiggle at the end there. So side, side, side squiggle for similarity. And the same thing for side, angle, side with a little squiggle after it. So just keep that in mind as we're moving through. Alright, on the next page, page 615, we're going to work through example 3 here. And we are tasked with determining whether these given triangles are similar or not. And so we're going to try to justify our answer by showing whether we can prove with certain shortcuts. Now, because I only see one angle here, I don't see all 3 corresponding pairs of sides that are given as given information. So I'm gonna suspect that a possibility of side, angle, side similarity might be working here. So that's what I want to check. So clearly we've got 2 pairs of corresponding side lengths and 1 pair of congruent corresponding angles. So remember, this side, angle, side is still in the same way as our congruence side, angle, side, in that this angle here is the one sandwiched between the sides. So when I'm talking about verifying the sides in a similarity shortcut, I need to verify that the sides sandwiching in the angles are proportional, not are congruent, are proportional. So MN, and we would suspect that that might be corresponding to MR. So we've got 4 to 6 is 2/3. And then the other pair of sides, and again it looks like I went from small to big, so I want to check my ratio that same way here. So you can see MP, the smaller triangle's longest side there is 8, and the bigger triangle's longest side is 8 plus 4, or 12. So because both of those have a ratio of 2/3, we know that our triangles MNP and MRQ, or NMP and RMQ, if we do it in corresponding order the way the book has it, are similar by the side, angle, side similarity theorem. Then the next question we're going to ask in part B here is whether this works in this case with a different shortcut. And again, I have no angles given to me this time, so I'm going to suspect side, side, side similarity, but I have to verify it. So because we're given 3 pairs of corresponding side lengths and absolutely no corresponding angles, we're definitely going to try side, 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 triangle similarity theorem. So what we need to do is to check that the ratios of the corresponding sides are equal. They've set up the first one for us, LM to GH, and it looks like they're taking, in this case, ratios of the lengths of the sides that are the smallest, the medium, and the large sides in the triangle. And that's a pretty good strategy here. So for LM, if we just take a quick look at where LM is on this right-hand figure, LM is the medium side, so we want to take the medium side of the small triangle, and that's why we have to GH. So that is 12 to 8, which reduces to 3/2. So that's our medium sides. Then we go to MN, and MN is our large sides. So 15 MN is going to correspond to the longest side of the small triangle, which is HJ, and that is 10, and that also reduces to 3/2. How about that? Then we're going to look at the third pair of sides, which is our small sides, and the small sides in each triangle. Again, we're looking though from the right triangle to the left is how we've been setting up our ratio each time. So the right triangle's smallest side is LN, and the left triangle's smallest side is GJ, which is a ratio of 6 to 4, which is also 3/2. So therefore, we can set up a similarity statement that LMN is similar to GHJ, and that's by the side-side-side triangle similarity theorem. Or if you want to just abbreviate it, side-side-side similarity. That works for me too. So we're given all three pairs of sides, and we've already checked that they're congruent. We don't need to check for congruent angles in this shortcut, and so yes, they are similar. I'll see you in the next class. But before we get back to class, make sure you go to your turns here, numbers 10 and 11, and hopefully you can see what we might suspect in this particular shortcut. Number 10 looks like we have some angles and sides given to us, so keep in mind, do we have side, angle, side? Keep in mind, may we have side, 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 or might we just have angle, angle? We'll see what we got here. All right, see you in the next class.